Hello once again, class. So this is a continuation of our discussion or presentations about the measures of variations. Okay, so the last presentation class that we talk about is how to find the coefficient of variations. So for these slides, we are going to talk about usual or normal values. So when we say normal or usual values, so again, we need to find the mean and the standard deviations of our sample data. So because we always use the mean and the standard deviation, so now we could say that the mean and the standard deviations are the two most important descriptive measures, because there are lots of let's say applications that we can use just based on the mean and the standard deviations. And of course, besides the coefficient of variations, we can also use the mean and the standard deviations to find whether or not a certain value or a certain score in our data set is said to be an unusual score, or if you are going to find out what are the ranges of values in a data set that are considered to be usual or normal values. So a usual or a normal values from the Chebyshev's theorem class, often as 95% of all observations are within two standard deviations on either side of the mean. So base class from this statement, it says that any values that is said to be usual or normal is within two standard deviations from the mean, while an unusual values lie above and below two standard deviations of the mean, and very unusual or extremely unusual values lie above and below three standard deviations. So if you're going to visualize this class in a normal curve, this is how it looks like. So we are only looking at the middle 95% class. So from the mean minus two standard deviations up to the mean plus the two standard deviations. So these are what we considered as normal or usual values. The remaining 5% outside the normal curve class or any distribution, so could it be 2.5% on the left and another 2.5% on the right? Those are now considered as our unusual values. So formula class is given by the mean plus or minus two standard deviation. So the plus here class is this is where the upper limit that we are solving, while if you use the minus, then we are looking for the lower limit of the range of usual values. So, okay. So, going back again to Bogart's and Berta's grades, so we know that Berta's grades are more consistent compared to Bogart. So, we wanted to find out what are the usual grades of Berta and that of Bogart. So, is it possible for Berta to have a grade as high as 92 or perhaps as low as 75? How about Bogart? Can we find a grade? What about if Bogart's grade is 93? Can we consider that as a usual grade for Bogart? What about if Bogart's grade is 78? So something like this class. So we want to find out whether or not these grades are considered to be usual. So all you have to do, class, is just find the mean and the standard deviations of our data. Since we already have here their values, both have a mean of 87, but they have different standard deviations. So what we're going to do now is we're going to solve the usual grades of Bogart. So the mean of 87 plus and minus 2 times the standard deviation of Bogart's grades of 2.83. So if you're going to simplify that, which is 5.66, but again, you have your plus and minus. So here you have to add and subtract. So 87 minus 5.66 class will give us 81.34, and 87 plus 5.66 will give us 92.66. So we are going to round this to a whole number. So 81.34 is 81, while 92.66 can be rounded to 93. So this means, class, that Bogart's usual grades are from 81 to 93. So as long as Bogart's grades are within this range, then those grades are considered to be usual. But if Bogart's has a grade of below 81 or above 93, then those grades of Bogarts are considered to be unusual already. So he can still have those grades class, but they are considered as unusual. So we only have about 5% chance that it will happen because by 95%, these are his grades. So we are sure or confident class that 95% of his grades are ranging only from 81 to 93. Now, what about Berta? Okay, since Berta has the same mean grade, but her standard deviation grade is 2.52, so 87 plus and minus 2 times 252 is 87 plus or minus 5.04. So when you multiply, 2 times 2.52 is 5.04. So again, 87 minus 5.04 is 81.96. And 87 plus 5.04 is 92.04. So rounding this into a whole number, so we have 82 to 92. So we can see clearly, class, that Berta's grades are very close from one another. Her lowest grade is only about 82 and her highest grade is only about 93. Compared to Berta, it's more wider range. Okay, so mas wider yung grades ni Bogart compared to Berta. That's the reason why, class, Berta's grades are more consistent compared to Bogart. Any grades that is less than 82 or greater than 92 are unusual for Berta. So that will be about 5% lang. So if it happens, that will be about, the chance now that it will happen is 5%. Because remember, in the earlier um, slides, class, that the usual values, the mean plus 2 and minus standard deviations, 2 standard deviations, this encompasses the middle 95%. So we are 95% confidence that these are the grades of Berta considered as usual. Okay, so Bogart's usual grades are from 81 to 93, while Berta's usual grades are from 82 to 92. Okay, so that's the reason why, class, we can now see why Berta is more consistent compared to Bogart, because Bogart's usual grades are more varied compared to Berta's. So this one again will give us an idea. So besides the coefficient of variations, now in terms of the range of their usual grades, we can see why Berta's grades are more consistent compared to Bogart. So if you have the summary, class, so from the previous slides, okay, so we have the mean and the median to be the same with their standard deviations. Then the coefficient of variations will tell us also that Berta's grades is less varied compared to Bogart's. And in terms of usual grades, we can see clearly why Berta's grades are very close from one another compared to Bogart. So if I am the class advisor, class, definitely I will choose Berta as the top performing student in the class. Okay, so if you're going to make a decisions which between Bogart and Berta will take the first honor. So something like that, class. Okay. Now, another example is like this one. So, the student's mean score in mathematics exam is 72 points with a standard deviation of 2.6 points. If a student in that class got a score of 80 points, is such a score unusual? So, how are we going to find out whether 80 points is considered to be a usual or unusual scores? So we have to use the concept class of the usual values. Okay, so we are going to plug in the lower and the upper limit. So 72 is the mean score with 2.6 as a standard deviation. So I separated, class, the plus and the minus here. So the lower limit is the minus, the upper limit is the plus. So 72 minus 2.26 is 72 minus 5.2, which is 66.8 or 67 when rounded into a whole number. For the upper limit, 72 plus 2 times 2.6 is equals to 72 plus 5.2, or that is 77.2 or 77 when rounded to a whole number. Now we see here, class, that 67 and 77 are the range of usual scores. So any students, as long as their scores are from 67 to 77, class, are actually considered as usual scores. Any score that is above 77 or below 67 are already considered as unusual. But since we are asked if a student had a score of 80 points, such score is unusual or usual. So we can see now that the usual scores are only ranging from 67 to 77. 80 points is a score above 77, which is now the cut-off points. Therefore, the score of 80 is considered as unusual. In fact, it is unusually high for such a score. If this happens, class, it only means that it is unusual case. So only 5% chance that this will happen. Okay, so that's an example, class. So another one is you found that, okay, in Jolly Wasp, the mean price of any burger is 155 pesos with a standard deviations of 15. While in McDonald's, the mean price of any burger is 160 pesos with a standard deviation of 15.5 pesos. So, find the usual price of burger in Jolly Wasp and in McDonald's. So, how are we going to do this, class? We're going to convert these values into its usual values. So, again, what will be the mean value for Jolly Wasp and the standard deviation? So, we can apply this one. So, for Jolly Wasp, the lower limit is 55 minus 2 times 15. That is 155 minus 30 is 125. And the upper limit, class, is 155 plus 2 times 15. That is 155 plus 30 equals to 185. So these are the range of the prices of burgers found in Jolly Wasp. So the usual price of burger in Jolly Wasp are ranging from 125 to 185. Any price less than 125 and greater than 185 are considered unusual. For McDonald's, the mean is 160 with a standard deviation of 15.5. So for the lower limit, 160 minus 2 times 15.5 is 160 minus 131. Sorry, 160 minus 31 will give us 129. For the upper limit, 160 plus 2 times 15.5, which is 160 plus 31, will give us 191. So you notice, class, that the range of prices of burgers in McDonald's are greater or wider compared to McJollibee. Sorry, in Jolly Wasp rather. So the usual price of burger in McDonald's are ranging from 129 to 191. Any price less than 129 and greater than 191 rather are considered unusual. So you already have an idea, class, on another use of the mean and standard deviations using or finding the usual or unusual values for the data. So in our examples from the okay, so far, class, we are not solving for the mean nor the standard deviations. We are just applying, okay, the results, okay, emanating now or coming from the mean and the standard deviation. So most often than not, class, the mean and the standard deviations are already given. All we have to do is to apply this in some problems, okay? So especially the usual values or the coefficient of variations, okay? So another one is your grade in mathematics during midterm was 95, okay? You found out that the class mean grade in your section is 88.7 with a standard deviation of 3.15. How do you describe your grade of 95? Okay. Do you consider it to be usual or unusual? So converting this again into its usual values, okay, to find out whether your grade of 95 is within the range or outside the range. So the mean grade in that class is 88.7 with a standard deviation of 3.15. So 88.7 minus, so the product of 2 times 3.15 is 6.3. So for the lower limit, 88.7 minus 6.3 is 82.4 or simply 82. While for the upper limit, class, so 88.7 as the mean plus 6.3, which is the product of 2 times the standard deviations, the total, class, is exactly 95. So indicating, class, that Since the usual grades in mathematics class ranging from 82 to 95, so your grade of 95 is considered as a usual grade. So any grade that is less than 82 or greater than 95 are the ones considered as unusual, either unusually low or unusually high. So this is now another example class of the use of the mean and standard deviations using the usual values.